Okay, so we are starting with just find the indefinite integral. So that just means it doesn't have parameters on it. So 2, the integral of x to the negative 2 dx. And so I'm just finding the antiderivative of that. So what would the antiderivative of x to the negative 2 be? I need to add 1 to the exponent. Okay, so x to the negative 1, but there's should be something else. Yeah, it should be negative. Because when I take the derivative of this, it's going to become positive x to the negative 2. And then plus c has to still go on all of these. And if you wanted to rewrite it, it's fine to leave it there. If you wanted to do this as negative 1 over x plus c, that's also fine. The book leaves it the first way, but if you don't like negative exponents, you can rewrite it. Let's see, 4. Wait. Sure, let's do 4. The integral of dt over t squared plus 1. What would the antiderivative of that be? Or what does it look like? How about if I rewrote it like this? Do we know what it is now? Or what it looks like?
Is it, what's it called? The tangent, but like not, it's the,
Cotangent?
no, it's the negative one.
The inverse one? Yes.
Yeah.
Yes. Okay, that would be the arctangent or inverse tangent of t, I guess. So we're writing it as t plus c. Yeah, so we didn't explicitly write those ones out this time, but don't forget the inverse ones.
I couldn't think of the word inverse. Like, I was just said, no one has to do a tangent.
Now, the way this was written is the way you're going to often see these kind of things, okay, where they're not going to write 1 over like I wrote it here. They're going to write it with the dt on top, okay, or whatever, dx, du, dv, whatever it is. So if you need to, write it out to the side and replace that with a 1 so that you see it. 6. The integral of, in parentheses, 2e to the x plus secant of x tangent of x minus the square root of x, close parentheses, dx. So with this one, we could just work through and do all the pieces at one time, or we can use the property here and split them into separate ones if you want to. This one's not too bad, so we can probably just leave it, but if y'all want to split it, we can. It's just more writing. Or just leave it. Yeah. All right, so what is the antiderivative of 2e to the x? 2e to the x What's the antiderivative of secant of x tangent of x? Secant of x. And then what about negative square root of x? How? Yeah, let's think about this as negative x to the 1/2. Yes. I have to write it out with the fraction ones to be able to see it and make sure. Am I done?
Plus C.
Bingo. Now you would be done with that one. Let's see. What? Use differentiation to verify the antiderivative formula. So 8 says the integral of cosecant of u cotangent of u du is equal to minus cosecant of u plus c. So what they want us to do is they want us to just take the derivative of this side and show that when we're done it's equal to this over here. So what is the derivative of negative cosecant of u?
So, cosecant u cotangent u.
Cosecant u cotangent of u. What's the derivative of c? C is a constant.
So it's 0.
0, so I'm done.
I got confused when you said just derivative and then antiderivative.
I hate antiderivative.
Yeah. I wouldn't worry about these problems too much. I just wanted to show you what that means when they ask you for that. That's not inclined to be something you're asked to do. So we're gonna push forward and disregard that a little bit. Okay. These next problems, I'm going to give you what the instructions say first and then the problem. Verify that the integral of f of u du is not equal to the integral f of u dx. Then this problem, number 14, is f of u is equal to u squared, and u is equal to x to the 5th. Okay, so what is the integral of u squared du? Yeah. 1/3 u cubed plus c. Now we are going to replace u with x to the 5th. So this will be 1/3 x to the 5th cubed. And so that ends up being x to the 15th over 3 plus c. now we're going to integrate u squared dx, which means with respect to x. So I'm going to put this value for u in here. Okay, so that's going to be the integral of x to the 5th squared dx, because I'm integrating with respect to x. And so that's equal to the integral of x to the 10th dx. And so when I take the antiderivative of that, what do I get?
One over 11 to x to x 11th plus.
Yep. So these two things are not equal, and so we have verified that this was true. Again, I'm not as inclined to give you one of these. I just want you to see it so that they're trying to show you that something's not true for when we get to the substitution part so that you don't make that mistake, basically. Okay, next thing. Use the indicated substitution to evaluate the integral. Confirm your answer by differentiation. We're not going to do the confirm part. We don't need to. All right. 18. The integral x cosine 2x squared dx u is equal to 2x squared. Okay, so we're pause here for a second, and I'm going to show you what u substitution is. U substitution is basically taking something that is a chain rule, okay, because disregard this. This would be a chain rule over here, and figuring out what can I replace to make this something that I know how to deal with, basically. So they've given us u, and anytime we are given u, we're going to find du also, because we need to rewrite everything in terms of u. So, what is the derivative of u over here?
4x.
Yes, 4x dx, okay? Because technically this is du dx, okay? But we've multiplied the dx to the other side so that we get all the x stuff on one side. This is why that one problem we were looking at yesterday out of the prep book, I said you don't really know what to do with this yet because it had two different variables and we haven't gotten that far for you to do that yet. So now, do you see a 4x in here? No. But what do you see in here aside from the 2x squared part?
An x.
Just an x, okay?
I see the derivative of 4x in there. I mean, derivative.
Okay, well, yeah, that's why we have this. Okay, but do you see x dx over here?
Yes.
Yes.
Okay, so I need to get everything besides x dx on the other side. So I'm going to divide by 4. Okay, so this is going to become 1/4 du is equal to x dx. So now what this does is this allows me to rewrite my integral as something that I can deal with. So we're going to have, use a different color, 1/4 the integral of the cosine of u. So I've gotten rid of that by replacing it with u. Then the x dx is being replaced with 1/4 du, but the 1/4 number will go out front because that's not changing, right? We all agree it's constant, so it's not going to change. So then the du goes here on the end. Now, is this something you know how to take the antiderivative of?
Yes.
Okay, and what would it be? Yep, negative sign, so I'm going to put the negative out here on the 1/4. So negative 1/4 sine of u. Now it's important to remember that that's a u. What else do I need with an indefinite integral? Plus c. So now to actually get the final answer, I have to plug this u value back in. Okay, if you leave it here, your answer is not right. So it's negative 1/4 sine of 2x squared plus c. And this would be your final answer. Now, these ones are nice. They're telling you what u is. As we go, we're going to have to find u ourselves. Okay? But we're going to stick with these for a couple problems, and then we'll go from there. All right, 20. The integral of 28 times 7x minus 2 cubed dx. And they tell us that u is equal to 7x minus 2. Okay, and that makes sense. That's what's in parentheses, being raised to a power. That looks like something that's going to be a chain rule, so that's a good guess. Okay, and sometimes I'm going to tell you when you get to doing these problems, you're going to pick a u, you're going to take the derivative of it, and you're going to be like, well, this isn't helpful, and you're going to realize maybe I need to pick something different. Okay, so don't be alarmed if at first you're picking the wrong thing and you're like, this isn't working. That happens a lot. Okay, especially if you end up in Calc 2 when you do by parts, you're going to be doing a lot of, guessing and stuff like that. But we get to skip that because we're not in BC calculus. So I have u. What's the first thing I need to find? Derivative. And what would the derivative be? 7 dx. Now, do I have a 7 dx over here?
Yes.
You have 7x.
You have a 7 and a
7 dx.
Yeah.
It can't be what's already been used. This is u. Ignore that.
Oh,
Then no.
Oh.
Then no.
You have a dx.
I do have a dx.
Yeah.
So what am I going to do?
5 by 7.
Divide by 7. So this is going to be du over 7 is dx, or 1/7 du. Now, what is this constant out front? Like, what can I do with it?
Put it out front.
I can put it out front. So when I rewrite this, okay, I'm going to rewrite this integral as 28 over 7, okay, because 28 times 1 over 7. 28 over 7 times the integral. 7x minus 2 is u, so that's going to become u cubed du. Now, 28 over 7 is what? 4. And then I need to take the antiderivative of u cubed, which is what?
1/4
1/4 u to the 4th.
du.
Plus c. Now, 4 and the 1/4 are canceling. I'm going to replace u with 7x minus 2. So my final is 7x minus 2 raised to the 4th plus c. So when you go back and look at it, I mean, it kind of makes sense, right? Like when you see it, it's kind of like, yeah, I might could have gotten there without it, but substitution makes this way easier.
Yeah.
And that's the goal of substitution, is trying to make our life easier.
Can you technically use substitution with like any antiderivative? Like the one.
You could, yeah, like a couple of the ones we were doing in the last section, we could have, probably would have been smarter to use substitution, but you didn't know that yet.
So if we're struggling, like on a quiz or something, we just use.
That's fine, yeah. Now that you know it, you can use it on any of it. I'm not going to be like on the quiz, but you didn't know that yet on that problem, so you can't use it. No, once you know it, because it does make your life way easier. Now, they typically only do it in problems that would be chain rules,
Yeah.
but you can,
Well, you also gotta make sure to pick the right.
yeah. Well, and as we go, like, we're going to do quite a few of them where I'm going to ask you to tell me what you think u is, and then we're going to try it, and you might be right, you might be wrong. And we're going to just work through it, so. It becomes easier to pick when you have to do, so by parts, you have u substitution and v substitution.
Where'd V come from?
Well, that's the thing. So you have two different types of substitution in the same problem.
I'm glad I don't have to do calc too.
So
That sounds awesome.
it's actually easier than it sounds, but it's the set, like trying to pick the pieces until you're
Yeah.
familiar with it can be hard.
Yeah. Sounds worse, actually.
Okay, 22. The integral of 9r squared dr divided by the square root of 1 minus r cubed. Now, I'm just going to see if you can guess. What would you be? They gave it to us in this problem, but I'm going to see if you have an idea of what it might be.
You said you would be 1 minus r cubed raised to the 1/2.
I'd say that U is probably just 1 minus R cubed.
Yes, it's going to be just the 1 minus r cubed because I can deal with u to the 1/2. Okay, I can't deal with the chain rule within that as an antiderivative. So yes, but they gave it to us in this problem. I just wanted to see if we could figure it out. It's 1 minus r cubed. So what's my first thing?
I was about to fix it. Wait, square.
Take the derivative.
The deriv. That's a whip.
So it would be -3 R cubed. I mean squared. Squared. I saw that.
No, dr.
dr.
What did you say?
Okay. So, do I have
Done?
3r squared dr or negative 3r squared dr directly in there?
No.
I have the r squared dr part. So what do I need to do?
Divide
by
by
negative
-3.
Divide by -3. So negative 1/3 du is equal to r squared dr. Now, would you agree that this 9 up here is just a constant so I can pull it out front?
Yeah, why not?
So I'm going to have the integral of 9, well, and it's going to be negative, over 3, okay, so that's this part, times, let me just write it this way first, 1 over the square root of u du. I'm going to write it this way first, and then I'm going to go back and rewrite it in terms of the negative 1/2 part. So the negative 9 over 3 is -3 times the integral. So 1 over the square root of u would be the same as u to the negative 1/2 du. Now, what is the antiderivative of u to the negative 1/2?
Two u to the 1/2.
2u to the 1/2. Because when I take the derivative, put that out front, it becomes a 1, negative 1/2. Yep, so we're good now. What else?
Plus C.
Plus c. I'm going to try to ingrain this so you don't forget the plus c part. So now I'm going to have -6. I'm replacing u back. So -6 times the square root of 1 minus r cubed plus c. And if you left it as 1 minus r cubed, like raised to the 1/2, that's fine as well. Which way do they do it? They do it like I have it, but the other way is fine as well. Because that's how it started, so I guess that's why they do it. So what do we think so far? Easy, hard, undecided,
Mid.
I'm not hating it.
I'm not adding it.
better than chapter 5?
Oh, yeah.
Anything. Anything that's better than Chinese.
Concavity and
Bad
first
things.
derivative test, second derivative test.
The,
Yeah, I don't know how to do that.
the word problems.
Not even one.
It's gonna have to come back here in a month and a half.
What was the word problems?
Actually,
Oh, related rates.
Yeah, honestly, I'll just be like, I just like
skip that part of the exam.
Oh gosh.
That's a big chunk of the exam to try to skip. Especially in the short answer portion, because quite a bit of that's short answer questions.
Yeah, like related rates and tones.
Okay, I'm going to have you guys try to guess what you think U is again without me giving it to you. The integral of 8
Yo, pause.
times, what is happening? Y to the 4th plus 4y squared plus 1 times y cubed plus 2y dy.
It's gonna be y cubed plus 2y.
Alright.
So I have 2 that think y cubed plus 2y.
May I ask your reasoning or is it one?
My reasoning is
My reason is interesting. That's a good reason.
Let's say
I also will trust
I'm not
him.
sure.
you can be
He's always
Why?
letting you straight, and he won't change now.
Just say you can be Y.
that is what it's
Okay. Christian, you have an opinion?
What?
I'm talking to you. Do you have an opinion on which one should be you?
I'm too tired for this.
Option 1, option 2. Just pick one.
I spent all my brain writing notes,
I don't know.
and
Peyton?
like the first two examples.
probably bigger.
I just said the bigger one, but I don't really know which one it is.
Okay. So I'm going to narrow it down. It's not U is equal to Y because it doesn't change anything.
I know.
Doesn't make
I
sense.
just-
Okay. It's also not the smaller one because when I take the derivative of that, it's not going to give me anything to cancel out over here. So I'm going to try the bigger one. Okay. Now, that is what it is. It's the y to the 4th plus 4y squared plus 1.
So
It's always going to be the
how are
bigger
you
one.
supposed to know? It's always gonna be the bigger one.
I mean, when it's something like this. Now, do I really need to do U substitution on this problem?
Not really, because it's just
I guess
adding
not,
stuff.
but
Except
there's
for that
like
8.
a lot of.
It's adding stuff, but what can I do
The eight,
first?
You can take the 8
Move
out,
the
right?
8 out of the
Okay, well, I could pull the 8 out and then, yes, okay? I can, like, well, I'm assuming you mean, like, superfoil it.
Yeah.
Yeah, and I can do that, and then I just have a whole bunch of little terms that I can deal with.
Yeah.
Right? But that's a lot of extra math, and I'm going to tell you the U substitution on this is going to make it way easier and way less math on your part. Okay, so what is DU?
du is obviously 4y
Obviously.
cubed plus 8y plus e.
It's not an antiderivative.
Okay, then that's it. Oh, d whatever the term is.
Y?
DY.
Yeah.
So now, is 4y cubed plus 8y in there?
No.
However, what is in there?
Y cubed and dy.
Okay. Y cubed plus 2y and dy. How can I make this look like this?
Divide by 2. Divide by 4.
Take out a 4. So that would be du is equal to 4 times y cubed plus 2y dy. Would you look at that?
That's kind of crazy.
1/4 du is equal to y cubed plus 2y dy. So now this piece right here has become 1/4 dy. Nope, 1/4 du. Okay, this piece right here is equal to that. So I can take the 8 out front. So 8, I'm going to go ahead and put the 1/4 over here. So 8 over 4 times the integral of u times du. I might have hypothetically written this problem down wrong. There was supposed to be a square right there.
Where?
Right here. Which is why you would need U substitution for this. So that's just going to make that u squared. It's not changing anything else. I was like, I feel like this problem's too easy. Let me look. And I just didn't write it down right. Okay, so what's the antiderivative of u squared du?
1/3 u to the cube
1/3 u cubed
plus
plus c. And this is getting multiplied by 2. So that's going to be 2/3. I'm going to rewrite u as y to the 4th plus 4y squared plus 1. That whole piece is being cubed plus c. Now, it still would have worked with my typo, but
Yeah.
all right, let's do one where they don't give us u, and then it'll probably be time for the day. 26. The integral of secant squared of x plus 2 dx.
u is x plus 2q.
Okay, so yeah, so when we're looking for u, it's typically things in parentheses, things in a radical, things inside of a trig function. So good guess is u is x plus 2. So what is du? 1 dx, which I already have that, so I don't have to do any manipulation over here. That's just what that is. So now I'll write this as the integral of secant squared of u du. What's the antiderivative of secant squared? Tangent u plus c. Now I have to plug back in the tangent of x plus 2 plus c. Do y'all want any problems yet, or do you just want to wait till we finish the section tomorrow? Okay. We should finish this tomorrow. I think this was like a 4 or 5 day section, and we're definitely going to finish this by Friday for sure. Yeah.